Hi students, welcome to Komali Mam online classes. Today, solid state day 4. In this session, I'm going to teach you in-text questions from 1.14. Let's begin the session. Super concepts I'm going to teach you. When you are solving each question, you will get more grip over the concepts. Let us see. In a simple way, I teach you. Instead of typical process, I will teach you shortcut methods so that you get full confidence and you will be able to solve the questions. Let us see 1.14. If the radius of octahedral void is R, radius of atom is capital R. They were asking us, find the relation between small r and the capital R. See, this is the solution. Instead of following this solution, I'm going to teach you another shortcut method so that you can solve it very easily. For example, what do you mean by an octahedral void? If there are 4 atoms like this, in the same plane, 4 atoms like this. Between these 4 atoms, there will be some void. Now, put one atom on the top of this void, one atom down of this. So, that this empty space is in contact with 6 other atoms. So, it is an octahedral void. Now, why the name octahedral void is given? Because it will be having, this is 4 atoms in the same plane. One atom above the plane, one atom below the plane. Suppose here A, here B. Now this is in contact with these 4 and here 4 faces will be there, 4 faces. It will be having 4 faces. Same way this B also will form 4 faces like this. And because of those 4 plus 4, 8 phases, the name octahedral void is given. So the void present here is a octahedral void. How to find the relation? I'm going to explain you now. This is 4 spheres like this. And this is the void. If you join these 4 centers, it will come like a square. Okay. Now, what I'm going to do is draw one point at the center of the sphere and you just draw one straight line like this. From this center to the valency shell is R. From here to here, it is R. Got it? The bigger atom radius is capital R. This is a small r. And from here to here, the radius is capital R. That's it. Over. Bigger size atom from center to valency shell, it is capital R. And small size atom from valency shell to the center is small r. So how can we do is, formula is cos theta is equal to adjacent by hypotenuse. So cos theta, what is the cos theta here? Total angle is actually 90 because exactly it is in square. So angle is 90. In that half we are taking here, half. Here it is. So it is cos 45 degree, exactly half. Adjacent value means this capital R divided by hypotenuse is this small r plus capital R. Cos 45 degree value is 1 by root 2, which is equal to r by small r plus capital R. Now just do the cross multiplication. If you do cross multiplication, r plus capital R is equal to root 2r. Then how can you do it now? Just root r is equal to this r, if it comes this side, root 2 value 1.414 r minus r, then it will be 0.414 r. So your answer is radius of that small void is 0.14 times 0.414 times that of the capital R. Is it clear? Shall I go to the next question, students? See the next question. Copper crystallizes in a FCC lattice. FCC lattice with edge length 3.61 into 10 to the power of minus 8 centimeters. Show that the calculated density is in agreement with its measured value of 8.92 gram per centimeter cube. So I want to tell you, they're asking us to find actually density. Density is equal to rho is equal to Zm by A cube Na. What is this Z value? FCC means Z value for molar mass of copper is 63.5. A value is 3.61 into 10 power of minus 8. And this is whole cube into 6.023 into 10 power of 23. Now remove the points. 63.5 into 4. 5 4s are 20. 3 4 3s are 12. Plus 4 with 14. 6 4s are 24. 1. 255. And this is here 3.61 whole cube into 6 into 10 power of minus 8 whole cube is 10 power of minus 24. If it comes here, 10 power of minus 1. Now let us see 3.61 whole cube how to do. This is important because when you are doing calculation, you may feel difficulty. So I am going to tell you how can you do this. Now 3.61 whole cube. Three, 6, 1. 3, 6, 1. Now 3 3s are 9, 3 6 are 18, 3 1s are 3. 3 6 are 18, 6 6 are 36, 6 1s are 6. 1 3s are 3, 1 6 are 6, 1 1s are 1. 1, 6 plus 6 is 12. 1, 6 plus 6 is 12, 13, 3, 1. 8 plus 8, 16. 16 plus 4 is 20. And 9 plus 1, 10, 11, 12, 13. So 130321. Now 130321. 130321. 130321. Is it clear? Slide gone back. 3, 2, 1. Now what I'm going to do is I'm going to 361 I'm going to multiply. 1 3s are 3, 3 3s are 9, 3 0s are 0, 3 3s are 9, 3 2s are 6, 3 1s are 3. 6 1s are 6, 6 3s are 18, 6 0s are 0, 6 3s are 18, 6 2s are 12, 6 1s are 6. 1 1s are 1, 1 3s are 3, 1 0s are 0, 3 1s are 3, 3 2s, 1 3s are 3, 1 2s are 2, 1 1s are 1. So add diagonally 6 plus 2, 8. Add diagonally like this you should add. 3 plus 3, 6 plus 2, 8. 7 plus 8 is 15, 5, 1. See every numerical, everything in detail I'll explain you. Now if you want little you can speed increase you can and watch it. But maximum try to follow along with me. 10, 11, 11 plus 3, 14. 1, 10, 10 plus 16, 17, 7, 1. So 4, 7, 0, 4, 5. This is 4, 7. Some value came, no? 4, 7, some value came. So here, what I want to say is 3.61 whole cube value is I got 4, 7 some numbers. Here what I should do is I removed these points. So total 2 points per one number. Means whole cube means total 6 decimals I removed. 1, 2, 3, 4, 5 like this 6 decimal if I remove, I'll be getting 47. Okay, around 47 value I'll be getting. Then this bring here and substitute. This value is around 254 divided, it will come around 47 into 6. This 10 power of minus 1 comes up, it will be 10. Now 47 into 6, 6 are 36, 42, 4, 6 4s are 24, 26. 47 into 6. 42, 4, 6 4s are 24, 4, 28. Yeah. 282. 254 into 10 is there 0 by 282 means 282 tens are 2820 means it will come around 9. So I want to tell you calculated density which is close to the 9. Measured value is 8.92. So calculated is almost close to 9. So it is a correct. In such a way we have to solve. See the next question. Analysis shows that nickel oxides has a formula Ni 0.98 and O is 1. What you have to do is what fractions of nickel Ni plus 2 and Ni plus 3 exist. Here I want to tell you an awesome concept that nickel oxide, it is changing into Ni 0.98O. What is the meaning? In this NiO, 1:1 ratio they are, which means 100:100. 100 nickels are present and 100 oxygens are present. But whenever in this Ni is plus 2 state, how I am telling Ni is plus 2 state? Because oxygen oxidation state is minus 2. If it is minus 2, nickel will be plus 2. Understanding, students? Is a clear? Now, a nickel in plus 2 state, 2 nickels are left because here 98 and it is 100 if you multiply. So I want to tell you, NiO, nickel is 100, oxygen is 100, but out of 100, 2 are removed. 98 is there. I want to tell that 2 nickels are removed. See the technique how I am going to tell you. If you know this, problem solving becomes very easy for you. This is Ni, this is O minus 2, this is Ni2 plus, and next one is O minus 2, next O minus 2, Ni plus 2, 2 plus, next O minus 2, next Ni plus 2. Then we will continue like this. Fine. But here, 2 nickels are replaced. 2 nickels. So 2 nickels replace means what will happen? Actually, if you remove 1 nickel, nickel is having which state? Plus 2 state. So if you remove 1 nickel, that 2 plus charge should compensated by other nickel. See, this Ni plus 2 is went out. If it is going, other nickel says, hey, my friend, you don't worry. You are plus 2 charge, right? I will increase my charge 1 unit. Other nickel will increase the charge 1 unit. Why? Because nickel is in plus 2 and plus 3 state only. Depending on a question, we can identify it will be in a which state. So 1 Ni plus 2 misses, then 2 Ni plus 3s will be generated. So 1 Ni plus 2 miss. How many Ni plus 2s will be, Ni plus 3s will be generated? 2 Ni plus 3s. But according to the question, 98 means 2 Ni plus 2s are missed. So 2 Ni plus 2s missed means how many Ni plus 3s generated? 4. Double the number. Double the number will be generated. So Ni 3 plus how many it will be generated? 4. Total is 98 into 100. Then Ni 2 plus will be whatever the percentage you get, 100 minus this percentage if you do. Then you get answer. See here, 400 divided by 98. So 98 means which is close to 100. So your answer will become very close to 4%. And then 100 minus that close to 4% if you do, you'll get around 96%. So here the key thing, main focus thing is 1 Ni plus 2 is having plus 2 charge. That plus 2 will be compensated by 2 Ni other plus 2 molecules. They change itself to Ni plus 3. That is important thing. So this is the best method to solve. Next one is 1.17. What are semiconductors? Define. What are semiconductors? Define the two main types of semiconductors and contrast their conduction mechanism. Means what are semiconductors actually? Semiconductors are nothing but their conductivity lies between insulators and the conductors. See, these are the substances whose conductivity lies between those of conductors and insulators. Conductors and insulators. These are of two types. One is N-type semiconductors and another one is P-type semiconductors. What are those? N-type semiconductors, P-type semi. Let us see how that N-type semiconductors will be generated and P-type semiconductors will be generated. I am taking 14th group elements like silicon, silicon. It is a 14th group, so there will be 4 valence electrons like this. Silicon. 14th group. So how many electrons will be there, students? There will be 4 electrons like this. Now, what I'm going to do is, I am going to remove one silicon and I am going to keep silicon. I am going to remove. I am going to keep in that boron atom. Boron belongs to 13th group. If I keep a boron has only 3 electrons in the valency shell. So it can form only 3 bonds. 1, 2, 3. So this remains empty. Whatever, because it is not having 4 electrons to form 4 bonds. So this empty orbital, that empty place, we call it as a hole. These holes are responsible for the conductivity. That's why these conductivity. So these are called as an P-type conductor. Means holes are not having electrons. Electrons means negative charge. So opposite to that is positive. So simply we say this as positive holes or P-type semiconductors. P-type semiconductors. Now, what I'm going to do is, I'm going to explain you N-type semiconductors. What are these N-type semiconductors? Let us see. Silicon. I'm drawing silicon because it is in it shows the semiconductivity, and we will make doping. We will add some other group elements, and here what I'm going to do is silicon place. I'm going to keep silicon place. I am going to keep some 15th group element. What are 15th group elements? 15th group elements like arsenic. I'll keep one arsenic here. Whenever I keep one arsenic here, arsenic have 5 electrons in the valency shell. Silicon has how many electrons? Only 4. Arsenic is having 5 electrons, but it can form only 4 bonds. 1 electron will be extra. This electron is having negative charge. That's why these conductors are called N-type semiconductors. Is it clear what is the meaning of N-type semiconductors? Now, let us see the next question. Non-stoichiometric cuprous oxide Cu2O can be prepared in laboratory. In this oxide, copper to oxygen ratio is slightly less than 2:1. Can you account for the fact that this substance is a P-type semiconductor? So what I want to tell you is, we have taken Cu2O, but Cu2O, some actually ratio should be 2:1, 2 copper and 1 oxygen. But actually the ratio is less than that. What is the meaning? We will see it. Cu plus O minus 2. Cu plus, because in Cu2O copper oxidation state is +1. Then here simply one structure we will draw like this. O minus 2, Cu plus 2, O minus 2. Like this one structure is there. Here I want to tell you some of the oxygens are missed. Some of the copper is missed. Let us take one copper is missed. One Cu plus is missed. That plus one charge to compensate, this Cu plus changes into plus 2. Why it is changing into plus 2? To maintain the electrical neutrality. So here, hole is created. This hole is responsible for the conductivity. So these are called as P-type conductors. That's why, that is the reason they are P-type conductors. See, the ratio is less than 2:1. And whatever the Cu plus have been replaced. Cu plus is replaced by what? Cu2 plus. To maintain electrical neutrality, whatever the Cu plus goes out, it will be another Cu2 plus Cu plus will be converted into Cu2 plus. You can tell like that. Or you can also say 2 Cu plus goes outside. In that place, 1 Cu plus 2 will occupy also, we can say. And once that positive holes are generated, we call it as P-type semiconductors. See the next question, 1.19. Ferric oxide crystallizes in hexagonal close-packed array of oxides. Means, I will give you the simple explanation when compared to the NCERT. Check it out. Ferric oxides crystallizes in a hexagonal packing array of oxides. So, O-2 is having HCP structure. Let us say X ions are present. And then Fe plus 3 ions are present. 2/3 of octahedral voids. So 2/3. 2 out of every 3 that of octahedral voids. See, number of atoms are X. So octahedral voids will be the same, X. Then ion Fe3 plus will be, Fe3 plus is, ion is 2/3X and O-2 will be X. Simply to say, ion without charges I am writing 2/3, this is X, this is X. XX cancel, if it go this side, Fe2O3. This is a formula of that particular iron oxide, where oxide ions are occupying HCP and iron ferric ions are occupying 2 out of every 3, means 2/3 of the tetrahedral voids. See the next question. Classify each of the following as being either a P-type or N-type semiconductors. Germanium doped with indium, boron doped with silicon. So how can we do this? And germanium doped with indium, boron doped with silicon. Germanium, I want to write like this. Germanium means carbon, silicon, germanium, 14th group. So it will be having 4 electrons in the valency shell. 4 electrons in the valency shell like this. And now what you have to do is, you can, in this germanium place, you are doping with indium. Germanium is doped with indium. So remove one germanium, put indium. But do you know, indium is having only 3 electrons in the valency shell. This place will remains vacant. So P positive charges, positive holes will be present. So these are called P-type semiconductors. But if you dope, see the part 2 question. Boron doped with a silicon. So take the boron atom, boron. How many electrons, how many bonds boron can form? Boron can form 3 bonds. Boron can form 3 bonds like this, for example. What I am going to do is, now I am going to remove one bond from, I am going to remove boron. In that place, I am going to keep one silicon, because we are doping with a silicon. Silicon belongs to 14th group. It will be having 1 electron extra. that electron is responsible for the conductivity. So electrons are negatively charged. So we call them as N-type semiconductors. What are these semiconductors, students? Tell me. These are N-type semiconductors. Clear? See the next question. Gold crystallizes in a face-centered unit cell. What is the length of the side of the unit cell? For FCC, formula is 4R is equal to root 2A is the formula. So, they were asking us to find the length of the side, means A value. So, 4R divided by root 2. So, we can write it as 4R. 4 we can write it as root 2 into root 2 into root 2. Means root 2 whole square. Root 2 whole square means root 2 whole square means root square cancel 2 into 2. 4, no? So we can write like this. Why we are writing, ma'am, like this? Because this denominator we can remove. So our calculation becomes easy. That is the reason. That's why, you know, in your textbook, it will be mentioned A is equal to 2 root 2R. So, A is equal to 2 root 2R. 2 into root 2 value is 1.414. And atomic radius, that radius is given 0.144. So, multiply 2 4s are 8, 2 1s are 2, 2 4s are 8, 2 1s are 2. Then, just multiply 1414 0 0 0, no, not needed, right? 144. Let us see. 1 1s are 1, 1 4s are 4, 1 1s are 1, 1 4s are 4. 4 1s are 4, 4 4s are 16, 4 1s are 4, 4 4s are 16. 4 1s are 4, 4 4s are 16, 4 1s are 4, 4 4s are 16. So 6, 10, 11, 1, 10, 14, 15, 16. And here 1, then 10, 11, 12, 13, 3, 1. And you'll be getting 4, 5, 5 plus 5, 10, 0, 1. Then it will be 2. So you got here how much? One more time. 0, 1, 4, 4 and 1.414, right? Again, I'll do it. 2 into 1.414 into 0.144, because I want you to learn how I am doing the calculation. 2 4s are 8, 2 1s are 2, 2 4s are 8, 2 1s are 2 into 0.144. This I have to multiply, na? Correct. I have multiplied that. Fine. Anything, whatever the answer I got in that step, I can directly multiply with a 2. So I would have got it. Fine. Doing one more time. 1, 4, 4. 1 2s are 2, 2 8, 1 8s are 8, 2 1s are 2, 1 8s are 8. Correct? 4 2s are 8, 4 8s are 32, 4 2s are 8, 32. Again, one more time. 4 2s are 8, 4 8s are 32, 4 2s are 8, 4 8s are 32. So 2, 13, 1, 16, 20, 22, 2, 2 2s are 4, 6, 10, 13, 10, 13, 13 plus 4, 17, 1, 16, 17, 20, 0, 2. Okay, 4 I got. Then 4, 0, 7, 2, 3, 2. Total how many decimals I just removed? 1, 2, 3, 4, 5, 6. 1, 1, 2, 3, 4, 5, 6. So answer will be around 0.407 and all are in nanometers which we have taken. So 0.47 nanometers is the correct answer. Can you check it out? This is our answer. This is the answer. Next, 1.12 onwards up to 1.26. I will do it in the next session, that is solid state day 5. These are the questions which I covered from exercise of solid state. See you in the next class. Practice all these questions. Bye, love you.